My name is Kurt Sturla, and I run the Earth System Initiative, which is one of the sponsors of today's program. And the Earth System Initiative, as you might guess from the name, the Earth System, singular system, is an interdepartmental research center at MIT. It's been around for about 10 years. And a lot of what I do is actually try to help nurture, launch, facilitate things like the MIT Water Club. And I can tell you that the MIT Water Club is something that, honestly, it's probably the thing that I'm most proud of having been involved with over the last year and a half, ever since Simon Chung, who was one of the moderators earlier, came into my office in, I think maybe April 2012, talking about the idea of launching a water club to be something of a counterpart to the very well-established MIT Energy Club. And this kind of thing, this sort of student activated, and sort of catalyst kind of organization is, as Phil mentioned, I mean, the students have a lot of ability to really cause things to happen everywhere, but particularly also at MIT, whereas, it's something that's involved with the administration. There's a lot of bureaucracy. Things move fairly slowly. But this MIT Water Club, I remember the one thing I said to Simon when he came into my office that I was really, really focused on was, I was happy to sponsor, to be a sort of founding benefactor of the MIT Water Club. And what I was most concerned in was the club's ability to be sustainable, to actually set itself up, to have bylaws, to have officers, to have a regular ongoing presence and not just be something that might disappear when Simon actually finishes his PhD. And I'm really happy to say that I think they've done a great job. They're very well established, and I think you can see from this event today that it's an organization that's really having some impact. And I was very gratified to hear John Leonhard read that brief message from President Reif about how happy he was that the Water Club is here and that it's doing what it's doing. So I see we're kind of set up here. The last thing I want to say, though, is just as a general, I guess I have this moment here as the provider of the cocktail party afterwards. I get to say a few words. But so one of the things that he'd keep on here, I think what I hear a lot of when I come to these kinds of presentations. We can talk about science, we can talk about engineering, but very typically what comes up again and again and again is the notion of communication, of community, of cooperation, of collaboration, of breaking down boundaries between disciplinary silos, of, and this can mean, nations cooperating, it can mean states cooperating, bordering states, it can mean towns, it can mean political parties, it can mean professors who have offices down the hall from each other cooperating in all these kinds of ways. And that's what these kind of events are about, and that's why I like to sponsor these kinds of things, and why I think it's so critical. A moment to just step back, think about this big picture. And the big picture is what ESI is all about, Earth System Initiative. There's a reason it's Earth System singular, because in fact, the other thing that comes up all the time is how interrelated everything is, how much you can't really impact a system or make a change without considering all of these ramifications. It comes up in all sorts of ways. The unknown ramifications of releasing a particular contaminant, the unknown or ignored ramifications of using fracking to produce cheap natural gas so that you have a cleaner alternative to burn at your power plant. Everything's interrelated. That's what ESI is all about. And as a philosophical thing, it comes down to really, we like to think about this in terms of, it's almost as though, basically I think of these things in terms of human welfare. And I actually believe the term enlightened just came up. I think it was Phil again who used the term enlightened. But I think about these things as, an enlightened sense of self-interest, an enlightened sense of what constitutes sustainable human welfare. In my opinion, if we really understand what that is as a natural consequence actually benefits all of life on Earth, and indeed the entire global ecosystem, the entire biosphere. Because if we understand what's in our own best interests in the long term, it turns out that maintaining and sustaining the ecological systems and the services they provide to us is part of that. It is, in fact, the entire thing. And that's kind of what this is all about for me. So with that, and everybody's in place, I just wanted to, the idea here was we wanted to open this up, have a little bit more conversation. But as Phil said, because in fact it really is, the future of the students, really, in a lot of ways. And what I wanted to do was go back just briefly and revisit these 4 great panels that we had earlier today. In reverse order, actually, and just call on each of the moderators to just say a few words about what they view to be the important crux, the take-home message of what that panel was about. So if we could start with that.
Okay, great. Okay. Thanks, everyone. So I think one of the things that everyone has heard definitely is that the emerging water pollutant issue from a large number, different perspectives, in terms of the academia perspective, in terms of industrial wastewater treatment perspective, and monitoring perspectives, and also the regulatory perspectives. And I think that, as Kurt mentioned, this interdisciplinary view is very crucial to our future development, whatever field we're in. I remember first when I was listening on a environmental pollution, law of environmental pollution class, and the professor in the first class, he was asking what's the background of everyone in the student audience, and he was a little upset to see there's not as many chemical engineers that is interested in learning about the environmental pollution effects of the chemicals that they're manufacturing. So I think whatever field we're in, there's especially considering the environmental impacts, it's definitely important to branch out from your own field, to not just, it's important to go down one field and pursue the depth of it, but it's also definitely interesting to know all the ramifications of it. If you're developing a new chemical, you do want to learn about the regulatory perspectives and the environmental health perspectives, and especially with these emerging water contaminants, the reason that there is, it might be because some of the industries kind of straightforwardly looking forward to their own purpose instead of trying to understand all around all the things all the impacts that this one production might have. And I hope that in the future, us as students and all the young professionals here, and everyone here, so may be able to in the future when they're developing these kind of things to kind of think around all the perspectives and be able to benefit the environment and solve problems. Yeah.
So energy, water?
Energy, water. Well, energy is needed to make water, and water is needed to make energy. I mean, I think that's the biggest takeaway from the talk that I gave. But, I'm just got all these thoughts simmering in my mind from all the panels, and I'll just be brief and say that what really hit me was building a forum where as many people are invited to the table as possible. Of course, we have to make sure that the people being invited to the table have the science and are being the right people to invite, of course. But getting a large amount of perspective before building a new dam or building transmission lines to go from one country, from one part of your country to another, or building a new desal plant, and really, I mean, as humans, we're more. We can build more, pardon me, I got a lot of ideas floating around. We're more reactive than proactive. So we're better at dealing with short-term goals rather than very long-term goals. And this ties into what you're saying as well, Kurt. We have to start thinking about how we're going to be building our energy and water infrastructure for the next, 100 years, 200 years. And that's very, very hard to do. But I think learning how to do that is going to be important for sustainable living on this planet.
So for my panel, the Food and Water Nexus, what we learned from the panelists today is the agriculture problem is very localized and regional. Like in US, we don't have the problem of water. We have a lot of water, and we can produce a lot of food. And in fact, we are a net food exporter. But for countries like in Africa, they don't have water, they don't have land, and the crop yield is 10 times less than compared to US. So those problems are very different in different area. And from this, we also talk about different solutions during the panel. And I think what really strikes out to me is the big data and analytics. So basically, we can collect all the data regarding the soil, information about the soil, the seed, the weather, so that we can make better prediction. And then This all leads to precision farming, so we know exactly when to fertilize, how much fertilizer to use, and when we need to water them, irrigate them. So I think this solution benefits not just in US, but also in, it can be used anywhere, depending on if you have all of those data available. So this is where I see the main opportunity for students or for professionals. I think if we can develop those sensors and collect those data and analyze them and make a good predictive model, we can definitely make a good impact in agriculture field. And also we learned that we need to, for developing country, we need to involve different stakeholders. Gabriela mentioned about private partnership between the big company like Monsanto with the local government and farmers to help them, give them access to those knowledge, those data analysis knowledge to help them be more efficient in terms of farming.
I would just mention, so David, who actually did, excuse me, moderate the first panel, had to, what was he had a meeting with his advisor?
He had a thesis meeting.
Thesis meeting. So you have to have priorities in life, but Neha is going to fill in for him.
Okay, so when I was first thinking about who owns water as a panel, I was like an impression that, hold on, why is there that a question? Because in my impression was like, even if we run out of water, you can always just price it and that will solve the problem. And I think definitely after hearing today's panel, I don't think that's a solution. So I think today what we talked during the panel, it was a very holistic view of the problem. First of all, we put forward, what Sharmila kind of addressed, the point of equity. We do need water. It's like one of the basic necessities for the life forms. And that's why it cannot be equated to other resources which are currently we use, like whether we just talk about fuel or something which we can price and tax. So it's a different kind of commodity. And it has that equity aspect attached to it, which is often not spoken and just said, oh yeah, that's always there, but we need to think in a different perspective. We need to think what's realistic. But I think what spoke out of for me during that panel was like the equity aspect, the human rights approach to providing water to everyone on this earth is much larger and is much important rather than just thinking about, oh, hold on, we need to go into public-private partnerships, or we need to tax this, we need to put a price on this, and et cetera, et cetera. So in that sense, I think for me, the approach or the solution boils down more towards like being more self-accountable on what exactly are we perceiving water as. We should not be taking water as granted, of course, and we should understand that there is a serious problem of water scarcity and we will be running out of water, and there will be approaches from regulations and there will be private partnerships and stuff like that, but there's a huge lot of things we as an individual need to do and come up with solutions as an individual, which can in a whole sum will lead to the problem of making water equitable across the globe. So that was kind of my main takeaway from the panel.
So, and I want to mention, and I actually chose to go in reverse order actually, because for me, in a lot of ways, although I'm a geologist myself, so I'm an earth scientist, but when we were in my office talking about putting this together, and this notion of the who owns water, ultimately for me, in that question is encompassed, a lot of where the actual problem and potential traction solving problems lie. And so I want to put to you guys, it sort of float out there. It's like one of the things that just occurred to me one day I was talking actually was that, and it came up, I think, Frank Fisher was earlier saying, it's sort of, maybe it's a little bit irrelevant to talk about who owns water in a sense, but another way you could say it is like, okay, well, who's responsible for it then? So who's responsible for water? Who's responsible for protecting the resource? That's another way of looking at ownership. I mean, is water a human right? Is it a commodity? Is it a strategic resource? Is it a form of a weapon to be used in a dispute? I mean, all of these, and so it has a lot of. So I guess what I want to put to you guys is to think about from the standpoint, again, being a geologist. And Ken was here, and this is why I thought having Ken kick things off was so valuable, because really I can't imagine having a meeting about water without throwing up something about the hydrologic cycle and making sure that there's a general level of understanding of everybody about what we're really talking about in terms of, there's a lot of fresh water. It's a tiny portion of the water on Earth, but there's a great deal of fresh water. There isn't a global scarcity problem. There's a temporal and spatial distribution problem and a rate of recycling that the Earth can actually do in different places. There's effects of climate change. We have a tendency, what we do, I think, often is to, it's MIT, we're engineers. We talk a lot about the engineering of the solutions to problems, social engineering, government, actual technological engineering, economic, financial engineering. We also recognize that we've actually, and generally speaking, we create our own problems. So we engineer our way in, and we try to engineer our way out. And I think that one of the points that came to me from the first panel, and I think across the board, was the degree to which, as a component of this communication, of the collaboration, is the importance to sort of institutions, the ability to actually make intelligent, informed choices about how we're going to govern ourselves and the way we use water or interact with the biosphere as a whole. So with that sort of in mind as a philosophical, these are different parts. We had to separate this into pillars. It's so hard to get away from silos, and we're going to give panels. So then we talked about this. Well, there's this panel about this and a panel about that. So it's very difficult for us to organize information without finding ourselves back into silos. So I invite you to sort of break down the boundaries a little bit between your panels and have a little conversation about that, and then open it up to comments and questions from the audience.
Sure.
But anybody want to just jump on that?
Yeah, I did an internship at Berkeley back in 2009, and that's the first time I was exposed to the idea of emerging water pollutants. And I was working on nanotechnology at the time, and a big question on my mind is what happens when I throw these samples down into the drain. Granted, I don't think it was going right into the San Francisco Bay, but sure, the lab had its own treatment system. But it was definitely a question on my mind. And coming to MIT, there are people working on nanotechnology, and I said, and they're working on nanotechnology to reduce the or to increase the energy efficiency in power plants. And so, that's just one way to break it down: emerging water pollutants and energy-water nexus. There's, we want to put things into silos, but really there's just a ton of problems that require solutions, and they're not always engineering.
And to add to that, my current research at MIT is more into wastewater management in hydraulic fracturing, and most of us have been reading newspapers with articles saying that there was a groundwater contamination because of the produced water from fracturing activities. And right now, the current situation with this kind of water produced in fracturing activities, the chemical profile of these water is very complex. It's like you have traditional contaminants, which is you can talk about salinity and stuff like that. But as the fracturing activity is increasing, you see barium, you see radioactivity compounds, you see variety of types of bacteria. And it's kind of the current scenario is the way they dispose it. It's also, again, a problem. Okay, first of all, the flowback profile is totally different. So that kind of goes back to the emerging contaminants, that what kind of contaminants like radioactivity, though it's at a very small scale, but then couple that with the increasing intensity of fracturing and that water being discharged into the surface water, how will that lead up in next 10 years or 15 years or maybe 20 years? Will that turn up into kind of a contaminant which is right now we need to study up and make sure that these are the effects of this, and this is what we need to make as a precaution. So what Phil said was enlightened precaution. So that kind of very easily fits into the work at least I'm doing right up here.
I would like to comment a little bit about who is being responsible for water. For example, Gabriela mentioned about we talk about biotechnology. For example, we genetically modify the crops, and also using different kind of fertilizer. So how would that affect the quality of the water? Are we polluting them, and how can we get rid of them? So I think we should be responsible in terms of what we put into the water system. And also, for example, another party that I play, I believe, is also the government giving incentive. For example, what I really need to talk about also not just food water nexus, but food, energy, and water nexus, because in U.S. we talk about a lot of subsidized to corn because we want to produce biofuel. Is that sustainable? So why is the government doing this? So I think in terms of the role, who's responsible in terms of the water, energy, and food, I think we need to really think about in the whole big picture and see who is responsible or not.
Yeah, and I think emerging water pollutants definitely has a connection with all the other panels as well. For example, with the treatment of like these contaminants, there is energy that's taken to treat these contaminants. With, there's places that has energy scarcity, and if you want to put in this much energy to treat them, like what's the balance? Like, how clean do you want it to be? How much more chemicals do you want to put in to make it clean? Like, what is the trade-off in terms of like the investment you put in to make it clean, and actually just having clean water? And so that is an interesting kind of perspective that connects to energy, and because there's energy needed to treat water as well. And in terms of the ownership of water, there's also who has, like, apart from owning just water, like who has the right to pollute water? So if if these pollutions are coming from pharmaceuticals, should they be the ones who's responsible for cleaning up? If they're coming from industry, should the industries be the ones who's responsible for taking up these new technology, or should the municipal side be the ones who's responsible? Eventually, a lot of them falls onto the municipal side, but are they, are they the ones that are they the ones that needs to be responsible? Like, who is responsible for cleaning this up? And what are some of the ways that we can encourage them to take responsibility? The treatments are expensive, and some of them are energy intensive. So if there is an ambiguity between who should be the one to clean up, there might be a problem, because then no one would really want to clean up the water.
And if I could add to that, I think among all the four panels, there's one kind of a distinction which I think was kind of touched in the food-water nexus panel, is like the difference between a developing and developed world. And I think today what we did was like more of a focused on the developed world. We were looking at solutions like whether it be energy-water nexus. We were looking at solutions what a developed world like a United States could do. Or if you're looking at emerging water pollutants, we are looking at regulations, what could come up, or frameworks, which in developed nations could come up with, or ownership of water. We're talking about privatization, or like, equity and stuff like that. But how does this whole debate across in all these four panels changes when we are located in a developing nations, where we are struggling with providing at least the basic amount of water? We are struggling to raise to get the highest level of economic development within the country. We're struggling to provide food, like the basic food quantity to the people. Amongst that, how does the gravity of these debates weigh when you look from a developing nations? I think that's a very important point, which requires a whole separate discussion, I believe. But it's definitely worth keeping in mind when evaluating all these panels in a holistic point of view.
Actually, I'm going to do one follow-up. If anybody, it's a time now where if anybody else kind of wants to sort of chime in or have a bit of a join in the discussion here. There's one.
Please.
I can see. Okay. We do have a couple. I want to just put, my own little last thing I could probably say on this is in thinking about that. I talked with a few people about this earlier, but we talk. It's like we're starting to stay out of politics a little bit, but really usually it seems like we start edging in. We're really talking about regulation. This idea that free markets are going to do the right thing or fix things in the most efficient way. There's an element of, and also what Neha just brought up, about when you think about the basically behavior modification of individuals, of cities, states, countries, nations, the entire world. What we do, I'm really sensitive. I didn't want to miss my opportunity. This thing about the bottled water was really key, because I think this all the time, about and it's an easy target, And I actually, I guess you guys probably brought the water, but I feel responsible for the water and it's fun. It's amazing. Even though I try to put on events that are compostable, recyclable, I was as aware of anybody the fact that I couldn't find a recycling container right there to put my bottle in. And it's funny, it's so difficult actually to put on these events and avoid bottled water. It is so hard to avoid this bottle of water. And in fact, I can tell you from personal experience that I've tried a couple times, and you put out pitchers of water with nice glasses, and then nobody ever drinks it because it's sitting there open, and they're afraid that that it's not clean. So it's a funny. Even this happens with the people here too. So it's this question of of how to, I mean, the equity of these things, but I mean, it seems like a great deal of this, the problem has to do with, we have enough knowledge and enough engineering prowess to be doing a better job that we're doing, maybe perhaps not a perfect job, but a better job, but we don't deploy it. And that seems to have a lot to do with behavior on all levels in all countries, developed and undeveloped. And to toss that out there and perhaps take a, sir, back in the yellow with that.
I have two sort of question points. One is, who's to speak for the status quo of the environment itself? Essentially, there exists fluorine, there exists arsenic, there exists calcium, there exists various contaminants, radioactive radon. You talked about having a forum where people get together. Is that aspect of the universe going to be able to speak in that forum? The other thing is, I question the need for responsibility. We as a society always want to assign responsibility to something. It's like asking the question, who's responsible for the existence of fluorine? And you go, wait a minute, it exists. And it's got a positive and a negative effect. Not everything comes down to somebody who's at fault associated with it. How does that integrate?
Responsibility doesn't just mean fault, it also means taking care, like being responsible. So another way you could say it would be to, who cares about water enough to actually steward it, would be maybe another.
Does anyone want to say something?
I mean, I posed the same question to Professor Larry Susskind when he was sitting in my seat. I asked, who's going to speak for the flamingos in Chile? I don't know if you were here in the first panel, but the environment sometimes doesn't have a voice, and I would say the best proxy are ecologists and environmentalists that can try and speak about those problems at this imaginary forum.
About it being the voice saying, don't do anything. Don't, your hubris is too great, don't do anything.
I don't know.
I actually didn't entirely, could you say that again a little louder?
There's always an action. As engineers, we look at there has to be an action, save the flamingo. What if the action is just stop for a minute and don't do anything? Because that's what nature wants to say to you.
I quite honestly, sometimes I feel like the progress is too great and too fast, and we don't have time to pick up the pieces on, what went wrong when we, put up all these coal-fired power plants, and you can't stop the wheels of progress. We just have to figure out a way to do it more sustainably.
Inaction is often the most difficult action to take. I think for humanity that's certainly the case, and whether it's in all kinds of ways. I mean, we were mentioning, but we engineer our way into these problems. I don't mean to, that's not a negative comment about engineering, it's what we do. We get out ahead of ourselves and then deal with the consequences. And it came up again, it's like Phil Geschwen, for example, talking about, the idea is like what we ought to be doing is trying to think ahead about the probable ramifications of the actions we take. So it's a, sir?
I'm sort of harkening back to a previous MIT event, Innovative H2O, and I was on a panel where we had a robotic pipe, a robot sensing pipes. But the point is, I guess when I'm looking at this panel, I think about one thing we haven't talked about too much today is just the whole plumbing, piping infrastructure. And you think, and I got to look at each one of you. Who's got responsibility? Well, if I'm a pipe manufacturer, I've got a responsibility to make a high-quality pipe that's not going to contaminate. I think food. If I'm a beverage manufacturer, well, what sort of piping infrastructure is my food and beverage water going through? Chemical contaminants. Well, we've got a ton of corrugated metal pipe out there. We've got a ton of PVC pipe out there. You think joints, compounds, glues, sealants that combine these pipes. And then energy. Again, if I'm cooling energy or I'm a coal plant and my water's going through those pipes, it just seems, I don't know, maybe a part 2 water summit could be, pipes, sealants.
Pipe sealants and leaks.
Well, yeah, leaks and the economics of leakage and who pays for that and the economics of that.
Yep.
It just seems like the whole piping infrastructure could sort of touch on each one of these panels.
That's a very good topic for us.
For the next one.
For the next one, I would say.
The water problem is so broad and covers a lot of different topics. And like for today, we just basically try to touch on the one that is easily seen, like the most closely related to us, like the food, the energy that we use, and do we have the right to own the water? So those are the most obvious answer that we see. That's why we put it together now as the first water summit. And I agree with you, yeah, the piping is a big problem, and we'd like to see what are the problems and what are the challenges and what are solutions there. And it's a great suggestion for the next event or the next talk around this topic.
And
Yeah.
to add to that, I think a takeaway, if I was like kind of from the field of like piping, and like I would like to learn more, like get to know about what role I could play on environmental stewardess in that field, I would see today's panel, at least the ownership of water and the emerging water pollutants, as kind of lens to look at the different fields and see, okay, these were the like different lens, and based on these lens, what can I do applicable to my field, at least as a starting point. I definitely feel, yeah, there is a way to go and like have definitely it's a good point, good topic for a second summit. But from today's discussion, I think we have given at least two lenses to look to different fields, not only just energy or food, just at different fields, and see that, okay, these are the lenses, and like, yeah, this is different issues which I can take on and like work on it. So
Yeah, just during brainstorming with Neha earlier, before for the topics that we're going to touch on, we were initially thinking about maybe we should go and dive into like the technology. Because at MIT, we need to curious and excited about technology. So maybe talk about technology in different area, like what's the breakthrough right now, what kind of problem we're solving. But then we think maybe water is still a relatively new problem and issues. That people are now starting to talk about it. So we think maybe it's better to just take a step back and look at a higher level, broad cover different topics. So yeah, I think definitely next time we will dig deeper into these individual problems.
So there was a gentleman right there.
We're all talking about the advantages, I mean, the problems that, so many problems with water supply and contamination and everything. But to solve this, don't you think that it has to be an economic side of it? Because, I mean, if it's just moral or ethical, for example, like third world countries, they pass through a phase of having dirty water before they clean their water, because it's an economic advantage to not care about it. So I mean, here it's nice to talk about having clean water, because the industrialization, all the process of having the smog in the 70s, we're cleaning everything, but how do you find economic advantages on?
if I could just start this conversation. I think you are completely right. There are no economic incentives in major of this stuff. Like, who would come out and speak for flamingos in Chile? I mean, why would I? I don't care. I mean, there's no economic incentive for doing that, at least other than moral incentives or something like that. But I think that's where our regulatory agencies come into play. Like, at least, for example, when you think about, I can speak for my field, like when you talk about hydraulic fracturing, right now they don't have any incentive to manage their wastewater. Or why would they care that when they are disposing their water to a surface body, the whole aquatic life in that surface water is destroyed for like ages? Or why would they care that their withdrawal is depleting all the aquifers like for permanently? But there are regulatory agencies which force kind of regulations that if these industries don't follow, they will have to pay. And that's where the economic incentives come in. And that's why, at least what I see now, hydraulic fracturing operators or shale gas operators are now investing money into developing systematic treatment pathways, or rather systematic disposal pathways, so that they don't have to bear the grunt of the regulatory agencies whenever that comes up, because they know they're going to come in. So that's one pathway where I think regulatory agencies are like kind of indirect way to force or provide economic incentives for people who, at least from the business side, to make them do things in a sustainable way.
Just to add on to that, so for a past couple of events with Imagine H2O, we're trying to look into water business. We always bring people from different areas, like not just the entrepreneurs, but also bring in someone from the EPA who knows the government policy, because that would definitely affect, like Neha mentioned, giving the incentive for people to do stuff to clean up the water. And we also bring in people who actually will fund just these kind of businesses, like the VC or private investor. So because they need to know, we need to know why would they invest in things like this. So we try to bring people from different areas to give a better idea like how we can solve this problem together in our events.
Yeah, and also as like in my panel, people were mentioning where exactly to stop the problem. So if the chemical is already like as someone has said mentioned in the panel, if it's already become $1 million industry, then it's going to be really hard to make anything to stop. But then it might be at the research and development stage that you actually there would actually be people who's coming in and saying that, so why don't we look at the ecological effects before it even develops that far? And so that might bring in a question about like in a stage of a project, like where should environmentalists come in, and where should they actually start thinking about environmental effects, and what is the most effective way and economic way to think about it. And there's also another, like as economic, there's also a branch of environmental economics where when people are actually developing a project, they put costs on the like kind of side damages that it would have. Like it sounds harsh, like they put like money numbers on human lives, like like if a death of a person, what kind of price would that be? They put cost values on that, but that might also be a practical management perspective in terms of considering environment and when you're developing your economic plan, because you need numbers, and even if it sounds harsh to put numbers on environmental values and properties, but that might be one of the really effective way to do it if that might be the case. Yeah.
Right. Our first panelist, one of the professors that made the opening remarks this morning, Franklin Fisher, was talking about shadow prices. So it all fits into there.
We're actually getting to the point where we're going to, need to sort of wrap things up. We could take another. We could briefly state a question. I think was there somebody over here who would raise their hand? Okay, two in the back. Okay, well, gentleman in the back corner. We'll just take another.
I think I like the idea of grand challenges because they focus. I think in the energy water nexus there is a fantastic grand challenge that people are working on, and that's the energy neutral municipal wastewater treatment plant. Grand challenge: can you make a municipal wastewater treatment plant energy neutral? So I think that's one thing. And the other quick comment, is I don't think necessarily it has to be antagonistic, between the industry producing and between the environmentalist or the water. I think everybody would have to gain in doing what we call manufacturing 2.0 or in process intensification, where in fact it's good for money, and it's good, there is a way not to be antagonistic in this development.
I didn't recognize you from all the way up across. Gentlemen in the back, but okay, we're gonna do. We're gonna take a couple comments and then just quick. Go ahead. I want to.
Yeah, thanks. Well, it seems like one of the common themes, and definitely a big takeaway for me, is there are a lot of different facets to this issue. You can't think about water without thinking about energy, about food. And so my question for you guys is twofold. The first being, do you ever get overwhelmed by the scale of this issue? And the second being, as young professionals, as young scientists, do you guys struggle to find a niche that you can feel like you're contributing a lot, feel like you're making progress in this field?
Yes.
I'm going to pounce on that question as a perfect segue opportunity for. I think certainly there are some answers to that. I want to release us to the nice, the nicer room where we can all continue the conversations in groups and individually. But that very issue, I was thinking about that. You think about these big, hard, and soluble problems for a while, and it can tire you out. It's been a long day. Your head can start to get really big, and so it's a good time to go have a beer, a glass of wine, and actually continue the conversation. So I want to thank everybody for coming, and thank the Water Club very much for such a great event.